Rice feeds 4 billion people every day. Growing enough to feed 56% of the world's population has always been a challenge. Now there's another. Cutting its carbon footprint. Rice is responsible for 10% of the world's methane emissions.
It is a big number, isn't it?
Yes, it is a big number. We have to put into context as well that rice is growing on almost 160 million of hectares.
Dr Adno Radnelson works with hundreds of rice scientists here at IRRI, the International Rice Research Institute in the Philippines, finding climate solutions for farmers. Dr Yvonne Pinto is the Director General.
What are the priorities here? Is climate change number one?
I would say climate change is certainly number one right now. I think I'm speaking as someone who's sitting in an island nation or a network of islands. The number of climate-related shocks and their severity is increasing, and it's really impacting everybody.
IRRI's agronomists devise farming methods to reduce rice's emissions, while its plant breeders develop new varieties for hotter, wetter, saltier and drier conditions caused by climate change.
It's a good responsibility. Everybody needs to take that responsibility, right? So I feel happy to carry it. I have no problem.
Growing rice produces the three most potent greenhouse gases: methane, CH4, nitrous oxide, NTO, and carbon dioxide, CO2. The main culprit, methane, is emitted by bacteria living in oxygen-free flooded soils. Nitrous oxide from fertiliser and CO2 from burning rice stubble. Dr Radnelson's projects target all three gases.
Ready?
In this trial, emissions are captured every 30 minutes.
Lagay. Sample.
We estimate how much methane is inside and emitted from the plant, how much nitrous oxide is emitted, and how much CO2 as well at the same time.
Her team's proven a decades-old water-saving practice of alternate wetting and drying of paddy soils lowers emissions.
It's range between 30 to 70%. And in average, we say 50%. But that's the range. But that's already quite significant, right? 30% of reduction, that's our target by 2030. And then when you get to 70%, that's way more than what we can expect.
It's now a leading tool in climate mitigation. She's also adding biochar to soil to see if it can absorb methane before it leaks into the atmosphere.
Do you think that scientists like you and others here at IRRI can make a very big change?
I'm quite positive and optimistic that we will get there. It may not be a low-emitting variety as you may expect, but a combination of technologies that will be really useful for farmers.
IRRI's been instrumental in many breakthroughs since it opened in 1960. Renowned agricultural economist Dr Howdy Bowie has watched on in admiration.
Well, back in the 1960s, the policymakers knew that population was going to be exploding in developing countries, and they were very afraid there'd be widespread famine. And so the Ford Foundation, the Rockefeller Foundation funded IRRI.
Concentrating funding in one place worked. Yields outpaced population growth and rice prices fell, saving millions of lives and keeping the peace.
There would have been suffering through famine, and then that would have been just a great deal of political unrest.
IRRI opened its gene bank in 1971. It holds 132,000 of the world's estimated 400,000 varieties. Australia's donated more than 200 varieties to what rice geneticist Vinu Ramia describes as a gold mine.
You name a problem in the world related to rice cultivation. I can give you an example how this gene bank has contributed to solve that problem. Whether it could be higher yield, either it could be tolerance to any disease, or any drought or flooding type of situation or nutrition in recent days.
This is one of 2 storage vaults. The temperature in here is kept between 2 and 4 degrees, and they give you a jacket. The one next door, though, is -18, and thankfully we're not allowed in. Every year, the scientists come and get 30,000 different varieties and grow them out in the lab and in the field to test that the seed is still viable. And Dr. Ramaya is convinced that in these shelves are varieties that will produce less methane when they're growing. They just have to find them.
Gene screening seeds takes time, but AI is speeding up the work.
So ever since Erie Gene Bank started in the 70s, till 2023, only 20,000 varieties were ever screened for flood tolerance. But using AI-based methodology, in one season, we can do 60,000.
Every year, 30,000 samples are provided free to researchers around the world, and Australian plant breeders are repeat customers.
More and more people are welcome to utilize. This is the only way we can tackle climate change.
Traditionally, rice seedlings are transplanted by hand into flooded paddies, usually by women. But genes found here are now in varieties which can be sown into dry soils. Direct dry seeding could cut methane emissions within a decade.
If there's no flooding, means there's no methane production, and it can eliminate methane production up to 90%. So it has drastic impact on greenhouse gas emission.
Subsistence farming needn't be tech-free. Erie is encouraging farmers to use drones.
It takes 5 people all day to manually or by hand sow a 1 hectare paddy of rice. It takes 1 person piloting a drone 10 minutes. And when a farmer needs to, they just swap out the tank so they can apply granular fertiliser or liquid pesticides and herbicides. It not only frees up family members to earn money in other ways, but results show that at harvest, uniform seeding produces more and higher quality rice. But the pressure's on scientists to breed new varieties faster, so farmers keep pace with climate change. Speed breeding techniques have cut breeding times from 6 to 2 years. Improving flood-tolerant varieties is vital in Asian countries like the Philippines, which had a record 6 typhoons in 4 weeks at the end of last year.
7 million hectares approximately is affected by flood, and this is because of the weather change.
Dr. Suresh Kadaru's team have developed a submergence tolerance gene that's extended plant survival times from 1 week to 2. And it can last 14 days?
14 days.
Fully submerged?
Fully submerged, 1 metre. This is for today, and I'm raising the bar for tomorrow. So that's that experiment there, wherein I'm looking for 21-day submergence tolerance.
He wants to future-proof farmers so climate-related crop failures don't tip them into poverty. Dr. Kadaru works with varieties that can withstand too much rain. Amelia Henry's looking for ones which thrive on very little. Like sugarcane, rice can produce a second crop. She's identifying the best varieties so farmers can get 2 crops from the labour and cost of 1.
It could help with adapting to climate change because we never know how much water is going to be available, and these crops are good at using up the residual soil moisture after the first crop was harvested. But we still need to identify the varieties that will perform even better.
Australia funds several Erie projects, including this $1 million greenhouse used for drought trials.
Almost all rice growing areas have some risk of drought. So especially South Asia, Eastern India, Nepal, parts of Bangladesh, the drought sometimes happens every year. So we need to develop new varieties that are higher yielding under drought for those farmers as well.
Australian brainpower is here too. Queenslander Dr. Damien Platten connects the gene bank with breeding programs. and he hasn't finished gene mining.
Oh, no. We've probably used effectively maybe 1% of that. So there's still a huge amount of potential in the gene bank.
He's confident the answers are here for Australian farmers dreaming of a rice industry in far north Queensland or the Ord in Western Australia. He says there's a sense of urgency here.
We need solutions to these problems that are occurring and are changing ever more rapidly. And in order to keep up with that and to keep ahead of that, we can't just have a steady state, steady as you go sort of approach.
Low emission rice farming is possible. But Dr. Radnelson says it can only be done at scale worldwide if farmers are on board.
They have to see the value in it. And at this stage, it's very hard to engage farmers to be sensitive to climate change, but they will be very much sensitive to reductions of inputs, reduction of a cost of production. So that's kind of like the main entry point of any technology that we have to develop for them.